So before we get started with any text pre-processing, let's explore our dataset a little bit more. We'll start with some POS tagging. So the first thing we're going to want to do is initialize our spacey model. So we'll do this with NLP equals spacey.load and then reference the model we want to use. Because one of our tasks is to determine the differences between fake and factual news, we want to split out the dataset into fake news and factual news, and then we can compare the POS tags that occur between each of the different datasets. We'll create our fake news dataset, just taking our data frame and splitting it out where the column fake or factual equals fake news. We'll then do the same for fact news and take our data frame and filter it to where fake or factual equals factual news. From this, we can then create our two separate spacey documents. So first, we'll take our fake dataset and create fake spacey docs. Because we're working over a data frame, we'll want to use nlp.pipe over our fake news text column, and then make this a list. We'll then do the same for the factual news, so fact spacey docs equals list nlp.pipe over our fact news text dataset. We then want to create a function to extract the tags for each of the documents in our data, so each of the rows in our data frame. So we create our function extract token tags that takes the argument doc spacey.tokens.doc.doc. It will then return text, the ent type, and the POS tags for each item in the document. You'll notice here we're not only extracting the POS tags, but the ent type for named entity recognition, which we'll come onto later. So now let's get stuck in and start tagging our dataset. First, let's take the fake dataset. We'll create an empty list called fake tags df. And then we'll specify the column names we want to use. So we've got token, NER tag for the named entities, and POS tag. We then want to iterate through each of the documents, so each of the rows in our data frame, and pull out the relevant tags. So we'll create our for loop for ix doc in enumerate fake spacey docs. We'll take the tags by using our extract token tags function that we created earlier, and the argument we provide is the doc. We then convert these tags into a data frame and give the column names as the columns we specified earlier. We'll then append these tags onto our fake tags df. Once we've run through each of the documents and we've populated our fake tags df, we'll then use pd concat to get it into the right function and assign this back to fake tags df. So we'll do the exact same thing for our factual dataset, so we'll create fact tags df, and then we can just copy the code down and switch it out for the relevant dataset that we need. Let's see what this looks like. We'll take fake tags df.head. And we can see here this dataset has been broken out into the individual tokens, named entities have been pulled out where appropriate, and each token has been given its relevant POS tag. If you remember from our earlier lesson, the next thing we'll want to do is take a token frequency count. So we'll create our POS counts fake, and then fake tags df.group by, and we'll group by the token column and the POS tag column. We'll then take the size of this group and reset our index. We'll then use the name argument to name the index as counts. Next is .sort values, and we want to sort by the counts, and ascending equals false. Once we've done that, we can take POS counts fake.head, and we'll specify we want 10 rows to be returned. So essentially what we're being shown here is the most frequently occurring tokens, their associated POS tag, and the number of times this token occurs within our dataset. So because we haven't cleaned our dataset yet, you can see that this is just punctuation and stop words. This isn't super interesting, obviously, from an insights point of view, but it definitely helps when you come to removing your stop words. You can reference this list and make sure that any kind of really frequently occurring words that you don't want in your dataset are properly included within the stop words. We'll then do the exact same thing for our factual dataset. So we can copy this code across and switch out the datasets from the fake dataset to the factual dataset. We'll run this, and again you can see the most frequently occurring tokens. Again, it's just punctuation and stop words, but it's really good to be able to see this, to visualize it, get an idea of what kind of words you want to remove later on in the process. The next thing we want to look at is the frequencies of individual POS tags. So how many nouns occur, how many adjectives occur, things like this. It'll be interesting to compare this between the fake and factual dataset to see if different types of tags are coming up more frequently. So to do this, we take our POS counts fake that we just created and use the group by again. Here we're just grouping by the POS tag and then we're taking the token. We'll then count these tokens and sort the values. Again specifying ascending equals false to get the most frequent first. So we can see here nouns have the most unique values, followed by verbs and proper nouns. Let's compare this now against our factual dataset. Again, we'll just copy that code across and switch out the appropriate dataset. And when we compare this, we see that the two datasets do kind of follow a similar pattern, with nouns, verbs, and proper nouns being the most frequently occurring tags. You could then ask yourself, okay, well, if this is similar, are the specific nouns that are being used also similar, or do they vary quite a lot between the different datasets? Let's investigate this by doing a deeper dive into the nouns used by each of the datasets. So from our POS counts fake, we want to filter this to where POS counts fake.pos tags equals noun. So we're essentially just taking our dataset, filtering it to where the POS tag equals noun, and then we're giving the top 15 results. These will give us the top 15 nouns used in our fake news dataset. So we've got the top 15 printed out now, and we can see that the most popular nouns are words like people, president, women, time, year, etc. Let's see if this is the same for our factual news dataset. Okay, so we can see that even though nouns are really common in both datasets, the words they use do differ quite a lot, or at least have different places in the frequency of how they're used. So we can see government is the top noun in our factual dataset, but in our fake news dataset, this is way lower. We also have words included in the factual dataset such as bill, administration, election. Election does occur in the fake news dataset, but again, it's much lower down. So it's interesting to compare these two lists and see, okay, even if the frequencies of POS tags and how often they occur is quite similar, the different words that fall under each category can differ quite a lot. If you want to, feel free to pause this video now and take a look through some different POS tags and see how the words vary between each of the two datasets. And if you're ready to move on, let's move to our next lesson where we look at the named entities between these two groups.